Hello everybody! Today we're going to be talking about ellipses. So this is section 8.4. This is going to be another 2-day lesson. So we'll talk about ellipses today and tomorrow. The goal today is to be able to describe the main features of an ellipse and to be able to write the equation of ellipse in standard form. So let's start with drawing a coordinate plane, so an x and a y axis, and we're going to draw an ellipse. So an ellipse is like an oval, so the center is at the origin, and I just picked a couple of spots, a little bit wider on the x-axis and narrower on the y. So first thing we'll identify are our vertices. So there are two vertexes, plural is vertices, and the vertex is on the furthest point away from the center. Those two closer points on the y-axis are going to be called covertices. So there's a covertex at the top and the bottom. And those will change depending on how the ellipse is oriented. Okay, so if it was like longer and skinnier on the y-axis, then that's where the vertex would be. Okay. That orange line is our major axis, and it connects the two vertices. So that's like our long midline. And then our shorter midline, that's our minor axis. And that connects the covertices. So far we have a vertex, covertex, major axis, and a minor axis. A couple more parts of an ellipse. There are two special points, F1 and F2, that are both focuses. Foci is the actual plural, so there's two foci, F1 and F2. They're both the same distance from the center and the same distance from the vertices. And now if I call point P any point on the outside of that ellipse, so any point on the ellipse could be point P. I just drew it there because I had space, but it could be any single point. What makes an ellipse is that if I find the distance from any point to the two focuses and add those together, so the distance from F1 to P and the distance from F2 to P, and I add those two distances together, they will always equal the same number for a given ellipse. So that number will change depending on if you have a different ellipse or not, but all of those distances will add up to be the same value. So again, sum of the distances from a point P to the foci, those will always add up to equal some constant value. We won't really use that concept today, but we will tomorrow. Today we're going to talk about the standard form of an ellipse. So our standard form is x squared over a squared plus y squared over b squared equals 1. So an ellipse is always in fraction form, and it always equals 1 when we add up those two pieces together. So if A is greater than B, we have a horizontal major axis. So it's like that first ellipse that we drew that's longer on the x direction. Okay. And if A is less than B, then there's a vertical major axis. Okay. So really just looking at your x squared and your y squared, whichever one has a larger denominator, that's going to be the axis which contains the major axis. If that makes sense. So if a squared is bigger, that means that the major axis will be horizontal in the x direction. So what the A and the B tell us are actually the locations of our vertex and our covertex. So A is the x distance from the center to the vertex. Put a co there in parentheses because if it's a vertical ellipse, then it'll be a covertex. But if it's horizontal, like the picture I drew, that'll be a vertex. So A is the distance, the x distance from the center to the vertex, and B is the y distance from the center to the covertex, or again, vertex if it's a vertical ellipse. So let's do an example. If I'm given vertices at -9, 0, and 9, 0, and covertices at 0, -5, and 0, 5, what is the equation of the ellipse? So here I'm just sketching my ellipse. Okay? So vertices are further out. Those are at 9 and -9 on the x-axis. Covertices are at 5 and -5. So looking at my picture, my A value is 9 because that's the distance from the center out to a vertex, and B is 5 because that's the center to the covertex. And we are going to keep it kind of simple and keep ellipses that are centered at the origin. They could really be anywhere, but we're going to keep it in this kind of format. Okay. So x squared over a squared turns into x squared over 9 squared. Y squared over b squared is y squared over 5 squared. We can simplify that a little bit. X squared over 81 plus y squared over 25 equals 1. Sweet. Alright, we're going to do some practice problems. So given this equation, I want to figure out where my vertices and covertices are. So first thing I can do is figure out my A and B values. A is 7 because 7 squared is 49. B is 8 because 8 squared is 64. And now I can figure out my vertices and my covertices. So I know that on the x-axis I have to go out 7 spaces from the origin to get to a point. So 7 in both directions. So I have 2 points at 7, 0 and at -7, 0. And on the y-axis, I have points at 0, 8 and 0, -8. So now you can figure out that your vertices are at 0, 8, 0, -8, and your covertices are at -7, 0 and 7, 0. Question 2. Here is a ellipse. It's drawn beautifully. Your goal is to write the equation. Okay, so write the equation. You can tell that A is 4 and B is 2. So x squared over 4 squared equals y squared over 2 squared turns into x squared over 16 plus y squared over 4 equals 1. Last problem, here is a formula of an ellipse. X squared over 100 equals y squared over 81, and that equals 1. Question is the major axis vertical or horizontal? It is horizontal, and that is because the value under x is larger than the value under y. So that means in the x direction, our points are going to be further from the axis. You're going to have a major axis horizontal. And what are the vertices? -10, 0, and oh, hey look, there's a mistake right there. That should be at 10, 0. I'm not going to re-record this because it's almost 10 minutes. So, our vertices are at -10, 0, and 10, 0, and covertices are at 0, -9, and 0, 9. Thank you for listening.